Here we go. We have a question pair with given sum in a sorted array. So you are given an integer array target and an array. You have to find the number of pairs whose summation is equal to target. So we have given this array, and if we sum up this and this value, we got 6. Then if we sum up this with this value, because the indices are different, so we can consider this 5 as a different element. So this is another pair, and the third pair is this. So there are in total 3 pairs. So we got this test case. In this we have to find the summation whose we have to find the pair whose summation is equal to 2. So first pair is this, then second pair is this, third pair is this and this value. So we got 3 pairs. Then fourth pair is this, fifth pair is this, then sixth pair is this. So in the third example, we have not find any pair whose summation is equal to 125. Now let's try to build the approach. It's a easy level question. So let's suppose we got this test case. So first pair is this value and this value whose summation is equal to 5. But um, let's talk about this test case. This is a crucial test case. If we sum up this and this value, then the summation is equal to target. First of all, I hope you are already got my point that we need to apply two pointer. So let's suppose we got this value and we have L and R, and the summation is more than target, greater than target. So we need to find lesser value. So we will update our R and we shift our R to here. Then the summation is 5. Yes, that's the target that we want to achieve. So this is one of the pair. So first of all, I will update my answer to 1. Initially we got answer as 0, now answer is 1. Then what should we update? So should we update our L or should we update our R? Now this is a very good question. So 1 and 4 we only got a single pair. So now let's talk about this test case so that you will have a clear understanding. We have this and this value. So the summation is equal to 5. Now should we update our L or should we update our R? So we will apply while loop for L separately and R separately. How? First of all, this is one of the pair. Then what we'll do? We have a start. So start is L plus 1. Start is L plus 1. Then we'll check. Is it equal to the previous value? Yes, it is equal to previous value. It means it will also make the same pair. So we need to update our answer first of all. Then we will try to find new value. So we will update our S also. Is this value similar to previous value? Yes, this value is similar to previous value. Then what we'll do? We will um, simply take this pair also. So our S is here and this is one of the pair. So just update your answer and it's time to shift our S. If our S shifts to next index, then this value is not equal to previous value, then we will directly go out of the while loop. It's time to start our loop from right hand side for R. So we got AND. This is AND. Is AND is R minus 1. Is AND equal to the next value? Yes, R is AND is equal to the next value. So this is one of the pair. It will pair up with this value. It will pair up with this value. So first of all, update your answer. Then it's time to find new value. So update your E. Is this value equal to the next value? Yes, this value is equal to the next value. So this is one of the pair. We got answer as 5. Then if we update our E to the previous index to this index, this value is not equal to the next value. So that's enough. So we have paired up this with this, this with this with this, and 3 to this value, 3 to this value, and 3 to this value. Actually, 3 to 2 is already marked, so um, that's why we got 5, and I marked 6, so it's my bad. So we got this and this pair. It's time to update our L as well as our R. L as well as our R, because we have paired up with L with L index and with R index. With L index and with R index, we have paired up to every single value that sums up to target. Now our L shifts here and our R shifts here. Is the summation equal to target? Yes, the summation is equal to target. The summation is equal to target. So first of all, update your answer, then start a loop for starting and for ending. First of all, check for starting. Is this value equal to previous value? Yes. So this will also pair up with R. This will also pair up with R. So we need to update our answer. If S shifts to next value, and you can clearly verify that our S value is not equal to the previous value, so we are out of the while loop. Then it's time to start the loop for ending. Is it equal to next value? Yes. Update answer. We have gotten one more pair, so this will pair up with this. Actually, um, the illustration is just for visualization, so you can visualize it clearly. We don't need to return the indices, we just need to return the number of pairs. So as if ending moves to previous index, and you can see 2 is not equal to 4, so we have paired up with L and R indices. We have paired up L and R indices to each and every single pair. If L update, if R update. So we have got this and this value. Is it equal to summation? Is it equal to the summation? Is the summation is equal to target? Yes. So this is another pair. So we got 9. And if starts here, and as you can see, start is not equal to ending, and we are like you can like if I take 3 and 3, and our target is let's say 6, so let me put one more 3. So you can argue that our L is here, our R is here, this is one of the pair, so we will update our answer. And if starts here, then start is equal to previous value, so this is another pair. Yes, this is another pair. Then we will update our answer. Then if S shifts here, so this is so S is also equal to previous value. Should we take this value? No, we will run our while loop only till start or S is less than R, because start and R should be different indices. So that's why now our R is here. Let's start a loop for ending. So we have ending, is ending equal to next value? Yes. So this is one of the pair. So we got 3. Now ending is here. Should we take this value? No. We will only run while L is less than ending. Ending should be greater. Yes. So this is another pair. So this condition does not hold true. So if I increment my L, if I decrement my R, we have gotten the same index. So this is the point where we are outside the while loop. So we have gotten 3 pairs. So let's verify it. First pair is this, then the next pair is this, and the next pair is this. So we have gotten 3 pairs. So I hope uh, you understood this question, you understood the approach. Now let's code this. So we have L and R. answer. While this condition holds, we have two separate indices. Find the summation. If summation is equal to target, then start a loop for starting, start a loop for ending. This is a crucial. This L and R pair, the summation is equal to target. So first of all, consider this value and consider for the duplicate values. So while this condition holds, first of all increment your answer and go to the next index. While this condition hold, we are traversing from backwards. So consider this pair and go to the next index. It's time to skip L and R index. So move L and R, shift L and R. If summation is less, we need more summation. So update your L. Summation is more, update your R. At the end, return answer. Let's submit this and let's talk about time and space complexity. One can argue that we have while loop and while loop, so it is while inside while, but so you can say that it is order of n square. But if you analyze the time complexity and you know how algorithm works and how algorithm analysis works, so then you will get a clear point that this is not n square, this is order of n. We have two pointer l and r, either we are incrementing r or we can or we are decrementing r. So you can optimize this point, you can optimize it. How? So now you can optimize this. What you can do is, we are taking answer, we are updating our answer, we are updating our answer. So this is this works, this code works, and we have solved this question. But I have a task. You can solve in this way also. First we have L, then we have R. So just to check how many values are there, just check how many values are there. This is one pair. Okay, we got it. Then we will iterate. Is this value equal? Yes. Is this value equal? Yes. Is this value equal? No. So we have this index. So how many values we got? On the left side, we got three values. So then we have ending. Is this value equal? Yes. Is this value equal? Yes. Is this value equal? No. So on the ending side, we also got three values, and at the end, our R will be here. So start is here, L is here. So this is you can say an optimization. So then it's time to calculate how many pairs we will get. So 1, 2, 3, then uh, 1, 2, 3, then 1, 2, and 3. So you can clearly see we got 9 pairs. So it's time to multiply L and left and right, or yes, left and right. So just multiply left and right and update your answer. So you can solve it in this way. So that's all about this question. So we have solved it in expected time and space complexity. I hope you have learned something new. Give this video a thumbs up, subscribe to this channel. Thank you all for